Hello everybody. So here we're doing average values in chapter 6.2. So I'm going to skip the introduction to the average values. I'm going to go straight to an example which I believe is more, it explains more, explains better. So imagine you have an atom with three possible states. And all these states have um, um, have some atoms in it, right? So you have two atoms in the ground state, which has an energy of sorry 0 electron volts, and then you have two in the second state with energy of 4 electron volts, and then you have one in the last energy state and it has 7 electron volts. So how do you find the average? Well, you add them all up and you divide it by the number of atoms. So you do 0 times 2 plus 2 times 4. Actually, I'm going to keep it the same. Uh, so 2 times 0 plus 2 times 4 plus 1 times 7, all divided by 5. This way, we find the average energy. Therefore, it ends up being 0 plus 8 plus 7 divided by 5 is equals to 3 electron volts. All right? But what if we break it down in a different way? What if we say that the first part is going to be 2 over 5 times 0 plus 2 over 5 times 4 plus 1 over 5 times 7. So now you can see that this 2 over 5, 2 over 5, 1 over 5 are actually just a probability. This is P1, this is P2, and this is P3. And this instead is the energy values. E1 times E2 times E3. So can we say that the average energy is simply going to be equals to the sum? I'm going to use S. I believe the book uses S. Let me just make sure so I keep the same. Yeah, okay, yes. S times uh, our probability, which is P of S, times our energy, so E of S. This way, we reduced a bigger problem to a much simpler one. The book goes through a demonstration, which is simply exactly what I said right here. Since they cannot show you that the 7 is the energy and the 150 is the P3, I did go through a longer demonstration, but they end up with the same result. And they actually add one more point. What if we could apply this theorem to every single average that we know? So, what if we could say, for example, that we have an x? It can be anything you want to find, the average of anything you want to find. It can be energy, it can be velocity, it can be temperature. It's going to be the sum of all s of all our values of x. So, for example, the velocity of a particle, the temperature of a particle, the energy of a particle, times the probability of that particle. Well, the probability, we said, is always equals to 1 over z times e to the power of negative b e of s, where beta stands for 1 over kt. So now we can rewrite our x average is equals to 1 over z times the sum in s of x s times e to the power of negative beta e of s. This is our average. This is pretty much all you need to remember. It's a very short, you can see, section. Um, very straightforward, I want to say. They just start with the word introduction, but then they end up with the same answers. I hope this was helpful. Let me know if you have any questions in the comments.